Good day, students. My name is Suri and welcome to today's class. I will be doing physics. So get your writing materials and your calculator. I'll be right back. Welcome back. Diving straight into this, we'll be looking at physics fast questions. So our question number 1 says, which of the units of the following physical quantities are derived? So I remember figure 1, we have area, we have thrust, we have pressure, and we have mass. Out of all of these physical quantities, the only one that is not derived there is mass. So look for the option that does not carry Roman figure 4, that has all three without Roman figure 4, and that is option B, which is Roman figure 1, 2, and 3. Moving on to question number 2. Our question number 2 says, the slope of a straight line displacement time graph indicates the dash. If you see a displacement time graph, this is a displacement time graph. So I have a displacement time graph. So I have displacement here. And I have time. So if I'm to find the slope of this graph, the slope of the graph is going to be the velocity. The slope of a displacement time graph is going to be velocity because I'll be having change in displacement over change in time, and that is velocity. So the correct answer to this question is uniform velocity. That is us to question number 3. So question number 3 says, a man will exert the greatest pressure on a bench when he dash. So a man will exert the greatest pressure on a bench when he stands on toes of 1 foot. So when he stands on toes of 1 foot, he will be exerting the highest amount of pressure, which is option E. Question number 4 says, when 3 coplanar and non-parallel forces are in equilibrium, Roman figure 1 says they can be represented in magnitude and direction by the 3 sides of a triangle taken in order. Roman figure 2 says their lines of action meet at a point. Roman figure 3 says the magnitude of any one equals the magnitude of the resultant of the 2 other. And Roman figure 4 says any one force is the equilibrant of the other 2 forces. Then they said, which of the following statements above are correct? Which of the following statements above are correct? All the statements are correct. Looking at all the statements, for a body to be in equilibrium, all of these statements are correct. So let's look at our options that involve all of these statements being correct. So, and that is option D, which says Roman figure 1, Roman figure 2, Roman figure 3, and Roman figure 4 are correct. So that takes us to the next question, which is question number 5. Question number 5 says a ball of mass 0.5 kg moving at 10 meters per second. So I have a ball of mass 0.5 kg moving at, so this is my M1, U1 is 10 meters per second, and then it says collide with another ball of equal mass. So my M2 is also 0.5 kg, which is at rest, meaning that my U2 is 0 meters per second. If the two moves off together after the impact, calculate their common velocity. So their common velocity is unknown. With this, we bring out a formula which says that M1U1 plus M2U2 is equal to V open bracket M1 plus M2. So if we input our values, this will give me 0.5 times 10 plus 0.5 times 0 is equals to V open bracket 0.5 plus 0.5. So this will give me 5 plus 0 is equals to V open bracket 1, and this will mean that my V is 5 meters per second. So looking at our option there, our 5 meters per second is option C. So moving on to question number 6. Question number 6 says, a body is projected into space with an initial velocity v0 at an angle of theta to the horizontal. Which of the following statements is or are true about its motion? Roman figure 1 says the total time of flight is v0 cos theta over g, and Roman figure 2 says the maximum height is v0 sine 2 theta over g. The Roman figure 3 says the range is v0 square cos 2 theta over g. Looking at all of these options, none of the option is correct. None of the options is correct. Ordinarily, your maximum height is supposed to give you, in this case, v0 sine square theta over 2g as v0 square sine square theta over 2g, and that is not present in any of the options. And your range is supposed to give you v0 sine 2 theta over g, which is also not present. So in this question, none of the options is correct, because even your time of flight is supposed to give you 2v0 sine theta over g, which is also not present. So the correct answer is not in these options. So question number 7 says, a catapult is used to project a stone. Which of the following energy conversion takes place as the stone is released? Option A says the kinetic energy of the stone is converted into gravitational potential energy. Option B says the gravitational potential energy of the catapult is converted into kinetic energy of the stone. Option C says the gravitational potential energy is converted into elastic potential energy. Option D says the elastic potential energy of the catapult is converted into gravitational potential energy of the stone. And option D says none of the above. Now, this question, if you look at this, there is no gravitational potential energy. The closest answer to this question would have been B, but the answer is none of the above, and the reason is because the catapult does not have a gravitational potential energy. Instead, it has an elastic potential energy. Assuming this option B comes with an elastic potential energy converted to kinetic energy, then option B would have been correct. But because it does not have gravitational potential energy, it has elastic potential energy, option E is our correct answer. So moving on to question number 8, it says a ball is thrown vertically upward from the ground with an initial velocity of 50 meters per second. So our U is 50 meters per second. And then it said, what is the total time spent by the ball in the air? So we're looking for the time of flight. The time of flight is unknown. They gave us G in the question as 10 meters per second squared. So the first thing we are going to do is to find the time it takes the ball to get to maximum height. The time it takes the ball to get to maximum height. And we know that from whenever a body gets to maximum height, the final velocity is 0. So if we have our V is equals to U plus GT, but in this case, because the ball is going upward to get to maximum height, we'll be having V is equals to U minus GT. So we'll find the time it takes for it to get to maximum height. So T here is unknown. So with that, we know that our V is 0. So I have 0 is equals to 50 minus 10T. So if I move this to the other side, I'll have 10T is equals to 50. If I divide both sides by 10 divided by 10, it means that my T is 5 seconds. So once I've gotten this, I know that my time of flight is twice the time taken to get to maximum height, which means that my time of flight is 2 times 5, and that will give me 10 seconds. So our correct answer to this question is C, which is 10 seconds. So question number 9. Question number 9 says, which of the following correctly gives the relationship between linear speed and angular speed of a body moving uniformly in a circular radius? So this question is just asking you for the relationship between omega and our linear velocity. So if you look at this, you know that our formula that connects our angular speed to our linear speed says that v is equals to omega r, which is option A. Moving on to question number 10. Question number 10 says the motion of a body in simple harmonic if the dash. A, if the acceleration is always directed towards a fixed point. B, if the path of motion is a straight line. C, if the acceleration is directed towards a fixed point and proportional to its distance from the point. And D, if the acceleration is proportional to the square of the distance from a fixed point. And E, if the acceleration is constant and directed towards a fixed point. The correct answer to this question is C, which says that if the acceleration is directed towards a fixed point and it is proportional to the distance from the point. So the correct answer to this question here is C. That is the condition for a simple harmonic motion to occur in a body. So that takes us to question number 11. Question number 11 says, which of the following statements about the gaseous state of matter is not correct? Which of the following statements about the gaseous state of matter is not correct? The molecules of a substance is in gaseous state if dash. A, if they are in constant motion. B, if they have different speed. C, if they have temperature, which is an average measure of the kinetic energy. D, if they have no intermolecular attractive force. And E, if they have a pressure which is determined by the number of molecules present. The correct answer to this question is D, if they have no intermolecular force. All substance, whether be it gases, liquid, or solid, must have intermolecular forces. Although the intermolecular forces in gases are very minute, but they must still have intermolecular forces of attraction between them. That takes us to question number 12. Question number 12 says, which of the following cannot be used to measure the temperature of a substance? Which of the following cannot be used to measure the temperature of a substance? First one says variation of pressure with temperature. Option B says expansivity of a liquid. Option C says change in the resistance of a conductor. Option D says thermometric effect. And option E says change in color with temperature. The correct answer to this question is E, which is change in color with temperature. Change in color with temperature cannot be used to measure the temperature of a substance. Question number 13 says, the clinical thermometer is characterized by having a dash. The clinical thermometer is characterized by having a dash. There's something that separates the clinical thermometer from the laboratory thermometer or any other thermometer for that matter is the constriction. A clinical thermometer comes with a constriction, and that is option D. It has a constriction. So that is also question number 14, which says that a given mass of a gas has a pressure of 80 Newton per meter squared. So we have our pressure, our first pressure as 80 Newton per meter squared. At a temperature T1 as 47 degrees Celsius. Then they said if the temperature is reduced, so we have a new temperature T2 as 27 degrees Celsius with the volume remaining constant. They said the new pressure is dash. So P2 we do not know. So if you apply your gas law formula, which says that P1 over T1 is equals to P2 over T2, we're just going to what? Find our P2. But before we do that, we have to what? Convert our temperature in Celsius to Kelvin by adding plus 273 plus 273. So this will give me 300 Kelvin, and this will give me 320 Kelvin. So if I impute this into our formula, this means that I have 80 over 320 is equal to P2 over 300. So at this point, if I cross multiply, I'll be having P2 times 320 is equals to 80 times 300. So I'll divide both sides by 320 divided by 320. So if I divide at the end of the day, if I have 80, so it means that my P2 is going to give me 75 Newton per meter square. So looking at our options, that gives us option B, which is 75 Newton per meter square. That is also question number 15, which says, which of the following is a reason why a concrete floor feels colder to the bare feet than a mat on the same floor during the rainy season? So if you have a concrete floor and you're walking on it, why does it feel colder than when you're walking on a mat during the rainy season? Option A says a mat is a better conductor of heat than the feet. Option B says the mat loses heat to the bare feet at a faster rate than the concrete floor. Option C says the mat loses heat to the bare feet while the concrete floor extracts heat from them. Option D says concrete floor is a better conductor of heat. And option E says mat is a better conductor of heat than the floor. The correct answer is option D, which says that the concrete floor is a better conductor of heat than the floor. So that's our correct answer, which is what? Option D. So that takes us to question number 16. Question number 16 says, in which of the following is the expansion of solid a disadvantage? In which of the following is the expansion of solid a disadvantage? A says the fitting of wheels in rims. B says fire alarms. C says the thermostat. D says the bimetallic strip thermometer. And E says the balance wheel of a wash. Now, in all of these, in the fitting of wheels, in fire alarms, in the thermostat, and in the bimetallic strip thermometer, these are all advantages of the expansion of solid, except in balance wheel of a wash, because precision is needed, and if the wheel expands, the wash will not measure the accurate time. So it is a disadvantage in the balance wheel of a wash, which is option E. Okay, question number 17 says, which of the following best explains why a person suffers more severe burns when his skin is exposed to steam than when boiling water is poured onto his skin? So when a person is exposed to steam, a person will suffer more severe burns because steam has higher amount of heat present in it due to latent heat of vaporization of steam. So if you look at our option, we're going to be looking at the option that has to do with latent heat of vaporization of steam. And that is our option E here, which says that the specific latent heat of vaporization of steam is released changing from boiling water to steam. So our option E here is the correct answer, because at the release of the heat of vaporization of steam, the skin will burn a lot more. So that takes us to question number 18, which says, which of the following statements about radiant heat is or are not correct? Option A says radiant heat cannot travel through a vacuum. Option B says rough surfaces emit radiant heat more than polished surfaces. And option C says dark surfaces absorb radiant heat more than bright surfaces. So looking at all of these, the only one that is not correct there is Roman figure 1, which says that radiant heat cannot travel through a vacuum. Radiant heat can travel through a vacuum. So it means that option A here is our correct answer, because it says I only is not correct. So question number 19, which is our next question, says 0.5 kg of water. So we have the mass of water to be 0.5 kilograms at a temperature. The temperature is 10 degrees Celsius. It's completely converted to ice by extracting the quantity of heat extracted is 188,000 joules of heat from it. If the specific capacity of water, C1 here is 4,200 joules per kilogram per Kelvin, calculate the specific latent heat of fusion of ice. So we're looking for the specific latent heat of fusion of ice. Now, the total heat that was extracted has already been given to us. So for us to solve this question, we know that our quantity of heat in this case is supposed to give me MC change in theta plus ML. because this is the amount of heat that was required for converting from 10 degrees Celsius to 0 degrees Celsius, and this is the amount of heat that was required for converting from 0 degrees Celsius, still in 0 degrees Celsius, to ice. So, for us to solve this question, we already know that the amount of heat that was required has already been given to us. So all we have to do is what? Impute our values, and then we solve the question. Now remember that the body was heated was reduced from 10 degrees Celsius to 0 degrees Celsius. So our change in temperature here is going to give me 10 minus 0, and that will give me 10 degrees Celsius. So if I impute our values, it means I have 188,000 is equals to the mass here is 0.5 times the specific capacity is 4,200 times 10. This is plus. The mass here is still 0.5 times our specific latent heat. So this will give me 188,000 is equal to, so this will give me, so I have 21,000 plus 0.5 L. So if I subtract, I have 188,000 minus 21,000 is equals to 0.5 L. So that will give me, so I have 167,000 to be equals to 0.5 L. So I divide both sides by 0.5 divided by 0.5. That will give me, and my L is 334,000 joules per kilogram, which is the same as saying that my L is 334 kilojoules per kilogram, and that is our option D, which is 334 kilojoules per kilogram. Okay, that is also question number 20, which says the temperature at which the water vapor present in the air is just sufficient to saturate it is called dash. So the temperature at which the water vapor present in the air is just sufficient to saturate it is called the dew point. So that is the dew point. That is the point where your dew starts dropping. So that is what? Option D. So that takes us to question number 21. Question number 21 says, which of the following instruments may be used to measure the relative humidity? The relative humidity of any space can be measured using an instrument called the hygrometer, which is option E. So that takes us to question number 22. Question number 22, which says, which of the following will affect the saturation vapor pressure of a liquid? Which of the following will affect the saturation vapor pressure of a liquid? And option A, we have temperature of the liquid, we have humidity of air, we have volume of the vapor, we have volume of the liquid, and we have mass of the liquid. The only thing that can affect the saturation vapor pressure of a liquid is the temperature of the liquid. So when the temperature increases, it affects it, and when it reduces, it also affects the vapor pressure of the liquid. So that takes us to question number 23. Question number 23 says, which of the following statements is or are not correct about the image formed by a plane mirror? Roman figure 1 says the magnification produces 1. Roman figure 2 says the image distance is the same as the object distance. Roman figure 3 says the image is real. And Roman figure 4 says the image is laterally inverted. The only one that is not correct there is that the image is real. A plane mirror does not produce a real image, it produces a virtual image. So we look for the one that has what? Roman figure 3, which is option C, because a plane mirror produces virtual image and not real image. So that takes us to question number 24. Question number 24 says, a transparent rectangular block 5 centimeter thick. So we have the real depth as 5 centimeters is placed on a black dot. The dot, when viewed from above, is seemed 3 centimeters. So the apparent depth apparent depth, when you observe the block from above, you are going to see the black dot as 3 centimeters. It said, calculate the refractive index of the block. And we know that refractive index is real depth over apparent depth. So that is to say that I have what? 5/3. So if you look at our option there, you discover that what? Option D is the correct answer, which says what? Our refractive index is 5/3. So that takes us to question number 25, which says the velocities of light in air and glass are 3.0 times 10 raised to power 8 meter per second and 1.8 times 10 raised to power 8 meter per second respectively. So I have the velocity of air, velocity in air to be 3.0 times 10 raised to power 8 meter per second, and I have the velocity in glass, to be 1.8 times 10 raised to power 8 meter per second. Then the question says, calculate the sine of the angle of incidence. So we're looking for sine I degree, we do not know, that will produce an angle of refraction. So our R degree is given as 30 degrees for a ray of light incidented on the glass. Now, for us to solve this question, for us to find sine I degree, we have to first find our refractive index. And we know that our refractive index is velocity in air over velocity in glass. And since both of them are times 10 raised to power 8, so I have 3 times 10 raised to power 8 over 1.8 times 10 raised to power 8. So these two will cancel out themselves, and this will give me 3 divided by 1.8. So that will give me 5/3. So I will take my refractive index to solve for our sine of the angle of incidence using Snell's law. And Snell's law said that our refractive index is sine of the angle of incidence over sine of the angle of refraction, which means I have my 5/3 is equal to sine of the angle of incidence over sine 30. And this will give me 5/3 to be equals to sine of the angle of incidence over 0.5, because sine 30 is 0.5. So if I cross multiply, at the end of the day, I'll have sine of the angle of incidence times 3 is equals to 5 times 1/2, which is 0.5. So if I divide both sides by 3, I divide this by 3. So that will give me my sine I to be 5 times 1/2 times 1/3, and that will give me 5/6, and that should give me 0.83. So if we check our option here, the answer to this question will be 0.8, which is what? Option C. So that is the question number 26, which says that an object is placed 36 meters from a converging lens of focal length. So they gave us our object distance as 36 centimeters, and they give us the focal length in question as 24 centimeters. And they said if a real image which is 4 centimeters high is formed, so our image height is 4 centimeters. They say calculate the object height. Object height we do not know. And from this question, we also do not know the image distance. So our image distance is unknown, and we know that for a converging lens, our mirror formula says that my 1 over focal length is equals to 1 over image distance minus 1 over object distance. So if I make our image distance the surrogate of the formula, we have 1 over v to be equals to 1 over f plus 1 over u. So if I impute my values, I'll have 1 over v to be equals to 1 over 24 plus 1 over 36. So this is 1 over v is equal to, my LCM here is 72. So If I divide 72 divided by this, I will get 3. So I have times 1, I have 3 plus 2. So that will give me my 1 over V is equals to 5 over 72. So if I cross multiply, this means that my V is going to give me 72 over 5. But that is not all. The question said I should find the object distance. For me to find the object distance, I have to tell them that my magnification says that I have image height over object height is equals to image distance over object distance. And that would mean that I have my image height, which is 4, over object height, which I do not know, is equals to my image distance, which is 72 over 5, my object distance, which is 36. So this will give me 4 over image object distance, object height is equals to 72 over 5 times 1 over 36. So this will cancel this and I'll have 2. So I have 4 over object height is equals to 2 over 5. If I cross multiply, I have 2 object height is equals to 4 times 5, and that will give me divided by 2 divided by 2. It means that my object height is going to give me 10 centimeters. So looking at our options, 10 centimeters here is option E, and that is the height of the object. Question number 27 says the ability of the eye to focus objects at different distances is called dash. The ability of the eye to focus objects at different distances is called accommodation. Accommodation is the correct answer. So when the eye focus object at different distances, we call it accommodation, which is option B. So that takes us to question number 28. Question number 28 says the change of the direction of a wave front because of a change in the velocity of the wave in another medium is called dash. So whenever a wave travels from one medium to another and there's a change in the velocity of the wave and the wave changes direction, it is called refraction. So the correct answer there is option A, which is what? Refraction. Okay, moving on, this question number 29. It says a source of sound produces wave in air of wavelength. So our wavelength was given as 1.65 meters. It said if the speed of sound in air is, so our velocity of sound is 330 meters per second. They said the period of vibration in seconds is dash. So we're looking for a period we do not know. And we know that our velocity of sound in air, or velocity generally of a wave, is f lambda. That's the product of the frequency and the wavelength. And we also know that our f is 1 over period, which automatically means that my velocity is lambda over period. So if I cross multiply and try to make period the result of the formula, it means that my period is going to give me lambda over velocity. So if I substitute, that will mean that I have my period to be equals to 1.65 divided by 330. So if I divide, my period is going to give me 0.005 seconds, which can be rewritten and say that my period is 5 times 10 raised to the power minus 3 seconds. So if you look at our option here, our correct answer is option E, which is saying that my period is 0.005 seconds. Okay, and then the final question for today, question number 30, says which of the following statements is or are not correct about a standing wave? Roman figure 1 says it is formed by the superimposition of two progressive waves traveling in the same direction. All points on the wave are vibrating with maximum displacement. And Roman figure 3 says it is formed by the superimposition of two progressive waves of different amplitude traveling in opposite direction. Now, each one of these options are not correct. Why? Because the first one, which says that it is formed by the superimposition of two progressive waves traveling in the same direction, is wrong. For a wave to be a standing wave, they must be traveling in opposite direction. They be traveling in opposite direction. And then it says all points on the wave are vibrating with maximum displacement. That is also wrong. Why? Because the nodes are at zero, so they are not traveling at maximum displacement. Then option 3, which Roman figure 3, which says it is formed by the superposition of two progressive waves of different amplitude traveling in opposite directions, is also wrong. They must be having the same amplitude for the wave to be a standing wave. So the correct answer to this question is option E, which says that Roman figure 1, 2, and 3 are not correct. We have come to the end of today's class. If you have any question, drop it in the comment section. I will attend to it swiftly. Don't forget to subscribe and turn on your notification bell so that when we drop the next video, you'll be notified.